This is a good real-life application of quadratic functions where we're trying to maximize an area. In this particular problem, we have a river. So here's my river. And this farmer is building a fenced-in area along this river with 3 sides. So here's 1, 2, 3 sides. He has a total of 320 meters of fencing, so that's the length of the fencing. We want to know what's the largest area he can enclose and what dimensions should the paddock be. So let's first label some of the sides here. Let's call this X, which means this side would also be X. Now, figuring out this bottom side, we know that we need to enclose these 3 sides with the fencing, and we have a total of 320 meters. So the bottom side is going to be 320 meters minus what I've already used for these, the left and the right side. So the left side is X, the right side is X, so together they would be 2X. The bottom length of fence would be 320 minus 2X, which is what I've already used for the left side and the right side. Now we need to figure out the area of this rectangle, I guess you could call it, rectangle without a top. So area is found by doing length times width. So 320 minus 2X times X, which we can distribute that X and we get 320X minus 2X squared. Notice this is a quadratic, so the area is actually a quadratic. We want to maximize this area, and if it's a quadratic, we know that the maximum can be found by finding the top point, which is also called the vertex. Now we've learned how to find the vertex. We have this nice easy formula, x equals negative b over 2a. So we need to recognize in this equation, b is the number that is attached to x, the coefficient of x, and a is the number that's attached to x squared, the coefficient of x squared. So b is 320 and a is negative 2. Let's go ahead and plug those in. So negative 320 over 2 times a, which is negative 2. So that would be negative 320 over negative 4. And if we calculate that, we get 80. So what does this mean? Well, this says that x equals 80. X equals 80. So this dimension will be 80. We need to find the other dimension. So the other dimension was 320 minus 2x. We know what x is now. It's 80. So we can find that other dimension, 320 minus 160. 320 minus 160 is 160. So it looks like the dimensions of this paddock will be 160 meters long by 80 meters wide. And we also need to find the area. So the area, let's just do 160 times 80, length times width, which gets me 12,800 square meters.